Welcome to the final unit of Math 10, and we'll be looking at solving systems of equations, well, in particular, linear systems. So what is a linear system? A linear system is simply two equations of a line, right? And what do we mean by solving? Let's go backtrack a little bit. Two equations of a line, so I've given an example here. We got line 1 and line 2 here. Right? And to solve it, we can take a couple of different approaches. Right? We can do a graphical method or an algebraic method. Right? In today's lesson, we'll be looking at a graphing method. So if I were to graph those two lines, it would turn out to look like this, as this graph shown before. What does it mean to solve the system equation? Well, when we're solving the system, we were trying to find out when are those two equations equal to each other. Well, on a graph, that's actually quite easy to see. They're equal to each other only at one point, and then that's when they intersect each other, when they both share the exact same x and y values. So if you wanted to solve this system, and the solution to the system would be simply the x value at this point. So x is equal to -2. And the y value at this point, y is equal to -3. So the solution is x is equal to -2, y is equal to -3, or we can write it as a coordinate system as -2, -3. Okay? At that point, both of these lines are equal to each other. Okay. Now you can always verify your answers by plugging your point back into the equation and seeing if the left-hand side ends up equal to the right-hand side. I'm not going to do that. I've written out the steps here on the sheet for you guys, right? And that's how you can just verify. Just plug it in and see if the numbers on the left-hand side equal the number on the right-hand side. So let's look at a few examples. So example 1a, you have a system of linear equations. What is the solution? That is the question. So the solution is where these points intersect. So that is at x equal to 2 and y equal to 1. Or as a coordinate, 2, 1. Right, pause the video and determine the solution for 1b. So the solution to this problem is where the lines intersect, and we simply read off the x and y values. Hopefully you came up with x is -3 and y is equal to 2. In the next example here, we're going to work from the equation of the lines. So we're not given a graph. So if we're asked to solve a system equation, one of the methods we can take is by graphing them. Right? So in the previous unit, we learned that there's actually a couple of different ways we can graph. Right? So one way we can graph is by converting lines into y-intercept forms. That's an easy way to graph. Another one is using by intercepts. So I'm going to take the first line here, and I'm going to convert it to y-intercept form. And the method that you use is up to you. Whatever you find the easiest. So I'll demonstrate a couple of different things. So I want this in y-intercept form, y equal to mx plus b, where y is positive and on by itself on one side of the equation. So I'm going to move the 2x to the other side by subtracting it. So I end up with y is equal to -2x plus 2. Now I can graph this where my y-intercept is +2. So let's put a dot there, and my slope is -2/1. So my rise is -2, my run is 1. So another point on the line would be right here, another point, 2 down, 1 over, 2 down, 1 over, These are all points on the line, right? Once you have 2 or 3 points, you can just connect the dots. Right? Okay. Now for the second line, I'm going to take a different approach. All right. So switch colors here. So you have x minus y is equal to 7. Yeah, we can easily convert it to y equals mx plus b by undo the intercept method. So the x-intercept, we set y equal to 0 and solve. So x minus 0 is equal to 7. So the x-intercept is x is equal to 7. So the point 7, 0. The y-intercept, we set x equal to 0 and solve. So 0 minus y is equal to 7, negative y is equal to 7, which means y is equal to negative 7, right? So the y-intercept is 0, comma, negative 7. So I'm just going to plot these 2 points. So we have our y-intercept at negative 7, x-intercept at positive 7, and then connect these points. Right. So what is the solution to this system here? It's when they're both equal to each other. So they're both equal to each other at this intersection point, which is, so the solution, that's my notation for shorthand for solution, is when x is equal to 3 and y is equal to negative 4. So the solution is, in coordinate form, 3, negative 4. Okay. So I'd like you to pause the video and try example 3. So your first step is to figure out how you want to graph this system of equations. So write it as y-intercept form, or you can use your x and y intercepts. If figure out a method, whatever method you think works best for you, graph these two solutions, graph these 2 lines, and come up with a solution for this system. In order to solve, you need to manipulate the equation to something that you can graph. I chose to do both in slope y-intercept form. So my first equation here in blue, where my slope intercept is y is equal to negative 2x plus 2, where my slope is negative 2 over 1, and my y-intercept is 2. The second equation was a little bit harder to work with because we had to divide by a number. So yeah, I moved the 3y over to the other side to make y positive. Then I divided by, then I moved the 15 over because we need y equal to something. Then I divided through by 3, end up being 1/3 x minus 5 is equal to y. So my y-intercept is negative 5, my slope is 1 over 3. So next, I graphed. So when you're graphing, this graph didn't give you any numbers on the axes, so you should write down some numbers. You don't need to write down every single box what it represents, but every few, just tell me what spacing you are using. I chose to go up by 1, so we have 4 and 8 as my spacing here. I just did my halfway points. So I graphed my 2 lines. Where they intersect is the solution. So the solution is right here. And at that point, x is equal to negative 3 and y is equal to negative 4. All right. So the next question, I want you to do it yourself as well, but I'll talk you through it. So Guy solves the linear system x minus 2y is equal to 12 and 3x minus 2y is equal to 4. And his solution is 2, negative 5. So we need to verify if his solution is correct, right? So your job is to graph these equations and come up with the solution. So the first step was to convert these equations into something you can work with. I converted both of them into slope-intercept form. The first equation was y is equal to 1/2 x minus 6, where my slope is 1/2 and my y-intercept is -6. My second equation, when I manipulated it, I had y is equal to 3/2 x minus 2, where my slope is 3/2, so my rise is 3, my run is 2, and my y-intercept is -2. So to verify if Guy's solution is correct, we have to know what the correct solution is. Now, I graphed these two lines. Hopefully your graph is very similar to this, right? And I found my intersection point of the two graphs to be right here at -4 and -8. Guy said the solution is +2, -5, which would be over here. So Guy's solution is not correct because the lines do not intersect at that point. The final question is a word question. And it goes, the Skyride is a red aerial tram that carries passengers up the Grouse Mountain in Vancouver. The Skyride travels from an altitude of 300 meters to an altitude of 1100 meters. The tram can make the trip up or down in 5 minutes, and it carries 100 passengers. There is also a blue tram that carries 45 passengers. This tram takes approximately 8 minutes to go up or down the mountain. So each of them travel at a constant speed. So first part of the question is create a graph to represent the altitude of the trams, right? And it says the red tram starts at the top and the blue tram starts at the base, right? So we need to graph the information here. So we've got a word problem here and we're given a graph here to draw on, but we're not given any axes, right? So we have to decide what goes on each axis. What are we graphing? Well, one of the variables is time. And I've mentioned this many times in the past. Now, time will always go on your x-axis. Going back, talking about our independent and dependent variables, right? And on our y-axis is what else are we graphing? Well, we're graphing the altitude, the elevation, right? So we'll say right. Next, we need to look at the numbers that we're given here and determine our spacings, right? I think this is about a, I don't know, 15 by 15 grid, looks roughly about it, right? So my times, the two times I'm given it is 8 and 5. Sorry, 8 and 5 minutes, right? So if I go even 1, 2, 3, 4, 5, each one of these represents 1 minute, I will be fine for spacing wise. The graph will be fairly large. So my altitude goes all the way up to the elevation is up to 1100 meters. So obviously we can't go up by ones, right? So if I go up by hundreds, I go 100, 200, 300, 400, 500, and this is going to be measured in meters, and time is measured in minutes, right? We should be able to graph the data given. 600, 700, 800, 900, 1,000, 11, 12, 13, 14, 1,500. Okay, so if you set up a graph, now it's just a matter of graphing the points given. So they said the red tram starts at the top. At the top, the elevation is 1100 meters. So the red tram at the top, 1100 meters is right there. And it says it takes 5 minutes to go to the base, and the base is at 300 meters. So 5 minutes and it gets to the elevation of 300. And we draw this line. Right. So next we have the blue tram, right? And it starts at the base. So the base is at 300 meters. Well, I actually drew the other line a little bit too far, didn't I? And go back here, because you can't go below the base. It does not make sense to extend that line. That line should just look like that. Okay, so the base is at 300 meters. That's where the blue tram starts. And it takes 8 minutes to get to the top. So at 8-minute mark, going all the way up, and it reaches the 1100 here. So connect to the two dots. And there we go. All right, so that graph represents the altitudes of the two trams. And the part B, it asks us, what is the meaning of the intersection point here? So we can read off the values easy enough. It's not asking for us what the values are. It's asking us, what is the meaning? What does this point represent? All right, so you need to put this into the context of the question. So the red tram started at the top and it's working its way down. The blue tram started at the bottom and it's working its way up. So the way that the intersection point is where they cross paths, right? So we can do a quick statement here. The point where the two lines intersect is where the two trams pass each other. Right. So try the homework questions, and as always, feel free to contact me if you have any questions.